are all these tubes, okay, and this little bubbler setup that I've got up here. These are 6 separated bubblers, okay? They're not connected. They look like they're connected. I mean, there's so much plumbing going on up here. Each one of these is plumbed separately, except for the outlet gas line. Okay, it ties into all 6 of them, but the outlet gas line does not touch the liquid, so it's completely independent of the liquid. So each one of these bubblers is completely separate from its neighbor, and as is the plumbing. Now, how I made this work, you can see that each of these 3/8, this is polypropylene, okay, which is very compatible with sodium hydroxide. And each one of these spacers, 2 of them are covers for the cell, obviously, and 2 of the inner ones are spacers, and I'll explain how those work in a minute. But you can see they're tapped, and these are 1/16 NPT black nylon fittings. And you can see that they are plumbed, they're drilled edgewise, okay, and then there's another hole that points towards the center of the cell, okay, and each one of these is manufactured that way, okay. See if I can flip this guy around. You can see, try to get it in focus there, this is drilled down to this point, and this, at the end of this point right here, corresponds with the hole in the plates that I just barely showed you. Okay, let me explain. Then also, on the bottom, down here, same exact thing as on the top. Okay, so what you have, or what I've created here, is a circulatory circuit that does not require a pump. Okay, so the gas that's produced in the cell comes up through each individual line, and each individual line goes to its own separate bubbler. You can see I've got it kind of bubbling away very, very slowly right now. I'm going to turn this up in a minute so you can really see it. Right now it's like running at just a couple of amps. Okay, but you can see that each bubbler has, you know, a little gas popping out of it. Okay, and as the electrolyte fills each bubbler, it has a drainage port that leads back down to the corresponding cell, okay, that the gas outlet comes from. Okay, I don't know if you are seeing that or not. And these right here are little T's with rubber caps, so I can pop these rubber caps off and I can drain the cell if I so desire. Okay, now there's a couple things to the self-circulating design. So the circuit is gas out, okay, and then electrolyte back in. And the process of forming the hydroxy gas is the pump. Okay, pressure is created in the cell, pushes foam, and it is foam. It's foam and gas mixed together. Okay, that action, that production action, pressurizes this entire circuit. Okay, and as electrolyte is pushed out of the top of the cell, it creates a void, a vacuum, so to speak, or a lesser pressure than the top, and electrolyte is allowed by gravity feed to refill the cell as it empties. So it's a continual circuit. This bubbler needs to be elevated over the cell, okay? Otherwise the recirculatory system doesn't work. So what I'm picturing is this part of the cell mounted low on the front of the vehicle, and the bubbler mounted high near the hood, okay? But in line with each other. You know, one can be right on top of the other, so you're still only taking up, you know, 3 or 4 inches of space. Okay? So this is a very complicated, very labor-intensive method of self-recirculation. Okay, why self-recirculation? The reason for self-recirculation is, number one, for cleansing. When you first break in the cell, you're going to produce some gunk. And I know I've heard people tell me that I'm using the wrong plates or whatever, blah, blah, blah. I use 316 stainless steel cut from Larry Gage from emitech.com. These are high-quality plates. They've lasted some of the designs that I've run on my car that Larry's cut. It's been, I think, almost 2 years now, and 0 plate failures, 0 plate failures. So Larry Gage from Emitech.com, word up, brother. Okay, so I used the right plates, I used distilled water, I used the correct electrolyte, but there can still be foreign material, fingerprints or stuff impregnated in plastic, and there is iron that leaches out from 316. There are better grades of stainless steel, but the cost begins to climb exponentially. So I know from experience that after a couple of cleansing procedures at 20 amps or so for a couple hours, you burn out, basically push out those impurities out of the plates. And after a couple of times, basically you end up with the typical yellow tinged water, and the yellow is the chromium oxide that we've talked about in some of my previous videos, which is not it's not precipitates from dirty water or dirty stainless. That's the a product of the electrolysis. With the self-circulating design, okay, what you get is a better cleansing of the plates. You don't have to go in, open this cell up, and clean the plates or flush out any deposits on the bottom of the cell. Nothing deposits down here, because it all gets pushed up out the top, and it ends up sitting in the bottom of these bubblers, which are much easier to flush than taking the whole cell apart. You can take these clamps off, unscrew the top of the bubbler, dump the junk out, and refill everything with fresh electrolyte. Okay, it's a little easier. It's actually a lot easier than trying to shake the cell around or having to disassemble it to make sure your plates are clean. This is a self-cleansing design, which is really cool. The second advantage of circulation is cooling. Because the liquid is moving through the bubbler and the tubes and through the cell itself, there is increased cooling. Okay, so there are huge advantages to circulating versus static cell designs. And so I've been working on trying to come up with a viable circulation design, and I think that I finally figured it out here with the BB-Smack Gen 5. Okay, so another aspect and another advantage of this self-circulating design is no foam. No foam, even when it's green. And the reason why there's no foam, there's two reasons. First reason is that foam does come out of this top tube, but by the time it goes through the bubbler water, you're breaking down some of that foam. Reason number one. So the foam is dissipated through the natural bubbler action. Okay. Reason number two. This bubbler offers pressure head of 4 inches of water or so. Okay. So there's that. Then there's a check valve. This is a 1 psi crack check valve. Okay. So already you're at a couple psi. Pressure helps to reduce foam. So the cell runs pressurized. Okay, and then down the line, I don't have one here. I've just got a cup sitting here, but I still use from the outlet of the 6 bubblers, I still will use a BB-Smack Gen 4 bubbler design, which the BB-Smack Gen 4 bubbler design is not specific to the Gen 4. That bubbler design can be used on any application, any cell application. It's designed to be universal. So I use it on this, and you've seen it featured in my GenSet test that I just posted. Okay, so you can use that bubbler design. That's also like another psi or 2. So the cell runs at a pretty decent pressure, 3, 4, 5 psi. That keeps the foam down. So the circulating, the pressure, it all acts to increase the amount. You want less foam because then you have more active surface plate area. Okay, so that's a huge plus. Okay, so now last thing I want to do is go over the actual construction of the plates. Okay, this is, like I said, polypropylene, which is compatible with the materials that we use. Okay, and I'm going to use this as an extreme simplified version of what's going on inside this working unit. Okay, so there would be a level of 3/8 polypropylene.